Here's the definition of what are called similar triangles, and this is another application of a proportion. Two triangles whose corresponding angles are equal and corresponding sides are proportional are called similar triangles. I've drawn two triangles here that are similar. I labeled the sides A, B, C of the first triangle and D, E, F of the second triangle. So given that these triangles are similar, the definition says that their corresponding sides are proportional. So we can write down the proportion like A is to D as B is to E. And we can also conclude that both of those ratios are also equivalent to C is to F. So A is to D as B is to E as C is to F. You can take any two of these ratios and set them equal to each other, and you have a true proportion. I'm going to do an example right now. In this example, we're given two similar triangles, and we're asked to solve for the sides X and Y. So one of our triangles has sides 10 centimeters, 8.75 centimeters, and X centimeters. The triangle that's similar to it has sides 16 centimeters, Y centimeters, and 20 centimeters. So first of all, to solve for side X here, side X corresponds with the side that's 20 in the other triangle. The base of the first triangle is corresponding with the base of the other triangle. So we can set up a proportion X is to 20, or X over 20, equals, and then we could say 10 is to 16. The left side of the smaller triangle is to the right side of the larger triangle. So as 10 is to 16. And then from there, we need to multiply both sides by 20 to isolate X. So we can just take both sides here, multiply by 20, and X equals, take your calculator and just take 10 times 20 divided by 16. So 10 times 20 divided by 16 is 12.5 centimeters. So there's X. The base of the first triangle here is 12.5 centimeters. And then to solve for Y, we need to just set up another proportion involving Y. So we could say Y is the right side here of the second triangle. We could say Y is to 8.75. And then we could say 16 is to 10. The left side of the larger triangle is to the left side of the smaller triangle. So make sure if you're going from the second triangle to the first triangle in your first ratio, that you go from the second triangle to the first triangle once again in your second ratio. If you're going from the first triangle to the second one, as we did in solving for X, make sure you go from the first one to the second one in your other ratio there. So to solve this proportion, we need to multiply both sides by 8.75. And that'll allow us to solve for Y. So the 8.75s cancel right there. And then Y is equal to, take your calculator and hit 16 times 8.75 and then divide by 10. And the result there is 14 centimeters. So we've solved for X and Y. There's another application of a proportion involving similar triangles and solving for sides of similar triangles.